Hello my dear friends, in this video we will going to learn about the first law of thermodynamics, which is the conservation of energy principle. So first law of thermodynamics deals with conservation of energy, right? So deals with conservation of energy, right? And from the previous videos we can also see that the energy, it is in the two form. First, energy in the form of transient, that means boundary phenomena, and other is the system properties, that means point function, right? And generally the boundary phenomena energy in the thermodynamics, it is deals with heat and work. Now what is say that if we write energy balance, so what is the statement? So this statement is say that the net change, the net change, that is either change, that means increase or decrease, the net change in the total energy, in the total net change in the total energy of the system during a process is equal to, during a process equal to the difference between the total energy entering and the total energy leaving. Entering and the total energy leaving. The system during the process, leaving the system during the process. That means it is deals with the process. That means what is say that is, if there is any system, right, and the total energy of the system and its change delta A is equal to the difference between the total energy in minus total energy out. So we see that the energy which is in the form of the energy which is in the part which is either in or out, and the energy which is part which is stored within the system. That means the energy which is cross the boundary and the energy which is stored within the system, and that is the energy in minus energy out from the system is equal to total energy of the system net change in energy of the system. This is called energy balance. This is called energy balance. Energy balance. This is called energy balance. And mind it, this energy balance is any kind of the system, kind of the system, and undergoing any kind of process, kind of the process, right? If you see, example here is that, what is the example? If you take example like that, if there is a container, right? This is a closed container, and there is a adiabatic. That means no energy interaction in the form of heat. And if you stir the system, so if you stir the system, that means you apply a work. And which work? Shaft work. Let's suppose shaft work 8 kilojoule. So this energy, that means this energy is in, there is no any out. So if we apply, that means energy in minus energy out is equal to delta E of system. So what energy is in? 8 kilojoule. What energy out? 0. There is no energy out. So the energy of a system, so what is the energy of the system? The energy of the total energy change of the system is equal to 8 kilojoule. If there is no energy, if there is no any chance of the energy cross to the boundary, either in the form of mass, that means there is no any chance mass flow, and there is no any chance of heat flow. So what is the energy is in that? All energy will be responsible to increase its system energy, right? Okay, so here we discuss about what is the, so the next target is that we will discussing about energy change, not transfer, energy change of the system. What is that? Energy change of the system is, what is that? Does mean what is mean? What is that? So we know that energy change, energy change is equal to energy at initial state, energy at initial state. Why? Because this is the property, minus energy at final state, right? So delta E, that means net energy change of the system is equal to energy at initial state, one energy at initial state. Yeah, you say that energy at, you can say that energy at final minus initial na? Change is always final minus initial. So the change is always final minus energy at final state minus energy at initial state, right? So energy at 2, energy at 2 minus energy at state 1. So if we see that if there is a system and system initial state 1 and it is final state 2. So you just subtract the energy at 2 minus energy at 1. This is tells that this is the energy of a system. This is the simply means the energy of the system. Now some facts. What are the some facts about the energy of a system? Let number first. Energy is a property, right? Energy is a property. So if the change of energy of a system is zero, that means what is the energy at initial is the same energy at final. That means there is no any change. It's a property, that means a point function, that means there is no any point change. That means when it is possible, when the system does not change, does not change during the process. Example, which process? Cyclic process. Why? Because if this is your P and this is your V, so during a cycle, what is the initial is the same as the final. So delta E in this condition, delta E of the system is 0, right? Number second, what is the point number second? Point number second is that energy, this energy exists in numerous form. Example, what is the example? If you take example number A, internal energy, which is in the form of sensible, latent, chemical, and nuclear. This is the internal energy. Number B, kinetic energy. Number C, potential energy. Number D, electric energy. Number E, magnetic energy. So this is all in the form, and the sum of all these energy, that means internal energy, kinetic energy, potential energy, electrical energy, and magnetic energy, is called the total energy of the system. So sum of all these energy called total energy, denoted by capital E, total energy of the system. So you understood what is the total? Total, that means sum of these all energies, right? Now point number third is that if electrical energy, magnetic energy, and surface tension effect surface tension effect. These all effects are negligible. If these all effects are negligible, called simple compressible system. Simple compressible system. So in the simple compressible system, the effect of electrical energy, magnetic energy, and surface tension effects are negligible. That means these three energy are very less effect as compared to the some of the other energy. So this energy can be neglected, then that system is called simple compressible system. Always mind it. Why? Because in the numerical this term frequently used. Now next point is that, what is the next point? Next point is that, point number next, that means fourth point. Fourth point is that, what is that? Then if we choose the simple compressible substance, then what is the energy left here? Internal energy, kinetic energy, and potential energy. So what is the energy change? Total energy change is the change in internal energy, change in kinetic energy, plus change in potential energy, right? So this is very important. This is your change in internal energy, and this change is associated with the intramolecular form of energy. Molecular form of, that means this is a molecular level, molecular form of energy, right? This is the point number next. And the point number fifth is that, what is the point number fifth? In practice, in general, most of the system, in practice most of the system are stationary. Very important, the stationary term. That is, what is the stationary? That is, they do not involve any change in their velocity or elevation during the process, right? So we can say that, say that for a stationary system, for a stationary system, what is that? Change in elevation is negligible. That means Z1 equal to Z2. That means change in potential energy is 0. Change in kinetic energy, that means V1 is equal to V2. That means delta Ke is 0. So if these two is 0, so what is the total energy change of the system is exactly equal to change in intermolecular energy, that means internal energy. So change in the total energy is equal to the internal energy when the system is stationary. Very important, I'm telling you, right? Now this is okay. What is the mechanism? So now, mechanism of energy transfer. previously we see that mechanism of total energy change. Now in this content we see that mechanism of energy transfer. That means transfer, not change. This is transfer phenomena. If this is transfer, that means it should cross the boundary. It should cross the boundary. That means it is not a property, is not a properties of the system. That means what is that? Energy in and energy out, right? So what is that? Number first, energy transfer to or from the system in the three form. That means energy transfer to or from a system in three form. The transfer phenomena is three form. Number first, heat transfer, Q. Number second, work transfer. W. And number third, mass flow. These three is responsible to energy transfer. That means responsible for transfer of energy. Transfer of energy, right? Now this three is the transfer form of energy. Now number second point, in which this energy transfer, so this energy transfer is not a point function, is not a point function. It is not a point function. It is a boundary phenomena. Right? Number third is that if the system is fixed mass, if the system is fixed mass, that means what system? Closed system. If the system is fixed mass, that means a closed system. So in this case, only energy transfer is responsible for, so energy transfer is only from either heat and work. This is only the form of energy transfer. So in general we can write that, in general we can write energy in minus energy out is what? Either in the form of heat in minus heat out plus work in minus work out plus energy due to mass in minus energy due to mass out. This is energy in or out, and this is equal to delta E of system, in generally we can write like that. We can write like that, right? Okay, no problem. Now, so we can write it is in this fashion that so energy balance for any system undergoing any kind of process we can write energy balance, energy in minus energy out is equal to total energy of the system change, right? This is in kilojoule. So very important, this energy is transfer, this is your transfer, and this is your change. This transfer, and that means net energy transfer, this is your net energy transfer by heat, work and mass. But this change, that means change in internal kinetic and potential energy. So this is your energy balance due to transfer and equal to due to change. So what is in the form of rate basis? Rate form. What is your rate form? Rate of energy in per unit time, rate of energy out per unit time is equal to change of energy of a system per unit time dt. This is your kilowatt. Why? Because kilojoule per second is equal to kilowatt. So this is your rate basis. Okay. So if the cycle process, if there is a system, if there is a heat is in and this your work is out, so this is delta E of system. Now if this system is executed in a cyclic process, that means 1 and 2 point are same cycle. So for a cycle, delta E of system is what? Is 0. So what is the energy in is same energy out. So if you net is equal to W out. This is for a cycle. For a cycle, right? Okay. Thank you very much.